Here we are going to design eccentric isolated footing in shape 2016. First of all, let us open shape 2016, then go to file menu, click new model, choose design code as you prefer. I am selecting IS456 2000. Design preferences. The clear cover for top and bottom for footing slab is taken as 50 mm. Okay. Unit is now currently metric, which is okay. Choose blank. Then first of all, define material properties. I am using M25 for eccentric isolated footing design. Define M25 material. Property M25 of concrete. Unit volume 25 almost. Modulus of elasticity for M25 is 25,000. Poisson ratio 0.2. Thermal coefficient of thermal expansion is 5.5 multiplied by 10 to the power minus 6. Control V. The characteristic compressive strength of M25 cube is almost 25. Okay. Again define rebar material for rebar material. Take it AFE 500 for rebar material. Unit weight of rebar material is this. Modulus of elasticity for AFE 500 is 20,000. Control P. Minimum yield stress is taken as 500 and tensile stress minimum tensile stress is taken as 545. Pascal. Then click OK. OK. Defining material property has been completed. Then define footing slab property. Define footing slab property. Define slab, add new material. Slab, here we have slab thickness 500 mm, slab 500 mm with concrete property M25. It is footing 500. Okay. Again define column as stiff slab property. Stiff 375 by 375. Here we have column with dimension 375 by 375, which has same thickness as that of footing slab for bearing the pressure above. Okay, and a copy of this which has been replaced 500 M25. Stiff is defined as, it is defined as stiff. Column is defined as stiff property. Okay. Define and assign soil solvent modulus. Soil subgrade modulus is defined as the multiplication of soil bearing capacity with factor of safety, which is divided by settlement. Here we have soil bearing capacity for sandy loam soil with density 1460 kg per meter cube is taken as 200 kPa with factor of safety 3. Settlement varies from 25 to 50 mm. Depth of foundation is 6 feet 1.83 meter. Overburden soil pressure is this. First of all, soil subgrade modulus is defined. Soil subgrade modulus defines soil as bearing 200 kPa with soil subgrade modulus 24,000. Soil bears only compression. Okay. Then after define load pattern, we just define dead and live. Column and soil surcharge load is assigned as dead load. Define load pattern, dead and live. Okay. Define load combination, 8 default design load combination for IS 456. Modify and show. This is not needed. Delete. Modify. This is service normal condition. Service normal, which is dead load plus live load. Modify and show. This is strength alternate. Modify and show. This is the factor load combination for strength ultimate. Strength ultimate is the factor combination of dead load and live load with 1.5, and service normal load combination is just the combination of dead load and live load. After defining load pattern and load combination, we draw slab and column. First of all, draw slab, footing slab using quick draw around points. The dimension of footing slab is 1.85 times 1.85. 5 times 1.85. Then draw column on slab. Draw column. Column is defined as strip property. Strip 375 by 375 with dimension 375 by 375. First of all, draw point. Column. Here we have column size 375.375. The midpoint for this column is 0.1875. 0.1875 minus 0.1875. Draw column as strip property with dimension 0.375. 0.375. 0.375. Column has been drawn. Now see quadrant rule for this drawing moving points areas. Provide some eccentricity for column, say 0.3 meter from corner. Provide eccentricity for this column, say 0.3 meter. Hit it, then move this column area by 0.3 meter by minus 0.3 meter. I am moving this column area in x direction 0.3 meter, in y direction minus 0.3 meter. Delete this point. Draw point again. The midpoint is 0.1875, 0.1875, 0.1875. Assign support data for soil property. Assign support data soil property, soil 200. Okay. Then assign load. This load is obtained from ETAB for corner column A4. The load is, I'm going to assign this load. This load is obtained for dead load plus live load combination for base reaction. Assign load, point load. This point load is also dead load. Assign this load, Ctrl C, to be size of load for punching chair is 500 mm thick footing slab. Okay. Then after assigning load is also completed. Assign surface load, overburden pressure, soil pressure. Surface load. Surface load 26.72 kilonewton. Assign, this is soil overburden surface load in gravity direction, which is 26.72 kilonewton. Now save and run the design analysis. File, save as, it is design for Eccentric isolated then run analysis and design. The settlement for this pudding slab is 7 mm, which is less than 25 mm. Display soil pressure for load combination service normal apply 178, which is less than soil bearing capacity 200 kPa. It is okay. Then display punching shear, which is less than 1. It's also okay. Soil deform set. For ultimate strength condition, the settlement is 11 mm. For ultimate strength condition, the settlement is also under the allowable settlement condition. Then design slab reinforcement for this footing. Before that, we use strip based design for designing footing slab. Draw strips for this footing slab. I am using middle strip. This is for transfer direction A. Now for longitudinal direction B, middle strip. Now middle strip has been drawn. Now again run, analyze and design. The settlement here, display deformed shape under load combination service normal. The negative and positive displacement just denote that the displacement is in opposite direction, upward or downward direction. We are going to view the maximum displacement 7 mm under service normal condition, which is allowable under strength ultimate condition. Maximum displacement is 11 mm under strength ultimate condition. The maximum displacement is 11 mm. It is okay. Then check soil reaction. We check soil pressure for service normal condition, which is 178 kilonewton, which is less than 200 kPa soil bearing capacity. It is okay. Punching shear is already okay, less than 1. Then display show slab design. I'm using strip-based design and impose minimum reinforcement. First of all, show top rebar only. Top rebar only for layer A. So values at controlling station. Top bar for layer A is very minimum. Suppose let's consider for layer B. Top bar is almost very minimum. It is first of all layer A. Number of bar apply. mm. Use 10 mm. Use 8 mm. Okay. The transverse top bar is 3 numbers of 8 mm. Swell strip top x direction. In x direction, the maximum number of top bar is 3 numbers of 8 mm die rebar. 3 numbers of 8 y direction. Y direction top bar is numbers of 12 mm bar. Y direction 10 numbers of top bar is not significantly needed for this. Check for bottom bar. Bottom bar is 13 numbers of 12 mm bottom bars in x direction. Bottom in x direction. 14 number of 12 mm die bars in y direction in y direction 13 number of y direction 13 number of 12 mm die 13 number of 12 mm die bars with spacing with spacing 1.85 with spacing 1850 mm divided by 14 number 142.3 with spacing as 142.330 mm. We got bottom reinforcement in X and Y direction, both 13 numbers of 12 mm diameter bars with spacing 142 mm, say 140 mm, and in top direction, in X direction 3 numbers of 8 mm die bar and Y direction 10 numbers of 12 mm rebar, and putting size is 1.85 meter by 1.85 meter, that is 6 feet. 6 feet by 6 feet. Thickness of 14 slab equals to 500 mm equals to 500 mm equals to 500 mm equals to 1.6 feet. 1.6 feet. For given A4 corner stand. Thus, design of eccentric isolated footing has been completed.